Hey guys, Scanner Danner here. I have my son Caleb with me behind the camera. Special thanks to Caleb. Special thanks to you guys for joining me. Today we're working on a 2008 Mazda 3 with an air conditioning complaint. Customer stated that he tried to add some refrigerant and made it worse. That was the history we had. I did do one thing off camera and I did check my pressures already. But I'm going to start you guys from square one. As I was teaching Caleb about air conditioning, I'm going to teach you guys too, and this should be a good one. So let's get started on the car. All right, so step one with air conditioning, as you can see, I have my safety glasses on. We want to be safe in what we're doing. Step two, I was telling Caleb off camera, there are two different size fittings for the low and the high sides of an AC system. This is an R134a system. It is not the newer refrigerant that they're using now, which I don't know the number offhand, but this is R134a. These are the fittings unique to R134a. Every system has unique fittings. So older systems had R12 refrigerant. They were different fittings too, Caleb. They were not even the same. So you could not connect an R12 car to an R134a machine or recovery machine or gauge set. They're all different. All right, so R134a sizes. This particular car has the fittings marked for us already. We have a high side one here and we have our low side back here. And if you don't know, it's really not a big deal. It's pretty straightforward as far as identification goes based on the size of them, okay? So this is an airline type fitting. This pulls back and you clip it right over top. And when I do that, it should lock on, but right now it is not depressing that valve inside. You have to wind this down to depress the internal valve. Make sure your gauges are off up top, right? They're closed. Connect your gauges up with your quick connects and then wind your fitting down. That depresses the Schrader on both sides. And now we can look at our gauges and see what we have. And we're just over 90 PSI. Same thing on the high side, low and high side gauges. And I've said this before in some of my other air conditioning videos that there is no low or high side of an AC system with the car off. Pressure equalizes and there's one pressure. So just get a pressure reading. I can say there's 90 on the low and 90 on the high, but I don't have to talk like that with the car off. There is 90 PSI in this system. All right, so what do we know by that? Number one, R134a refrigerant and our degree Fahrenheit scale closely match each other. Every refrigerant has what's known as a pressure-temperature relationship. And the pressure-temperature relationship for R134a is very, very close to our Fahrenheit scale. So it's about 90 degrees outside. We should have about 90 PSI in our system. What this tells me, to start with, we have enough refrigerant in this system for the AC compressor to turn on. That's where we are right now. Questions, Caleb? Remember, you're a student too, and people want to hear from you.
Yeah, you just explained that all to me earlier.
So we have enough pressure in this system for this AC clutch to turn on. We'll get to that in a second. I want to do just a little bit more of a lesson on the pressure-temperature relationship for you guys. Just give me 1 second. We're going to use this water container for our example. So a refrigerant is something that has a very, very low boiling point. So I believe R134a has around a minus 40 degree Fahrenheit boiling point. Above minus 40, you get it into an atmospheric environment that's warmer and it will start to boil and change from a liquid to a gas. So in a sealed chamber, the only way that you could have, if you picture this sealed chamber as our R134a refrigerant, there's a mixture of liquid at the bottom, vapor on the top. You picture this container, it has liquid refrigerant in there. How can we have liquid refrigerant in an environment where we're at 90 degrees? This should all boil off. If this refrigerant boils at minus 40 degrees, how could it possibly be a liquid? Look at a butane lighter, it's the same thing. You look at that liquid in the lighter, it has a negative degree Fahrenheit boiling point. minus 20, minus 30 degree Fahrenheit, whatever butane is. How can you have liquid? The answer is pressure over top. When we create pressure over top of a liquid, we increase its boiling point. So what happens in a sealed chamber like this container, you pull this out into a warmer environment, that liquid starts to boil off and it changes to pressure, gas in the top, and that gas pressure increases, and that is what increases the boiling point of the liquid. And then now we can have liquid in this environment, and it's because of the 90 psi of pressure above. It's raised the boiling point to 90 degrees. What happens when we change the temperature and make it 100 degrees outside? What happens to this chamber? We boil more of the liquid. More of the liquid turns into a gas. We raise the pressure more, and now we have 100 psi in here, and we still have liquid left over. Okay? All right, so here's what we don't know. Let's say that this container represents a full system charge. This is what we should have: a mixture of liquid and gas, 90 psi. Our pressure temperature relationship, we would say, is good. That means we have at least some liquid refrigerant. This is a representation of a full system charge. Mixture of both. I'm gonna drink some of this. I'm thirsty. I'm drinking all your water, Caleb. You notice I left just a little bit of liquid in the bottom of this, right? We still have a container right now that my pressure and temperature relationship would still hold true. So what I'm telling you guys is this first step does not tell us if our system is fully charged. It only tells us that there is some liquid refrigerant still left in our system because our pressure and temperature will be matching. The pressure temperature relationship will be holding true. So I hope that analogy makes sense. There's still some liquid left in there. If I raise the temperature on this, there's some liquid that will boil off and it will raise the pressure. How do you know when your system is low on charge? So this initial test can identify a low charge, and here's why. If I just get rid of the rest of the water, okay, no more liquid left, what happens if I raise the pressure or temperature on this now? Let's say that let's back the temperature down some. Let's say we have 60 psi on my gauges in a 90 degree day. What does that tell us? That tells us there is no liquid refrigerant left, just like this. Because what happens if this is, let's say, 60 psi of pressure in here, no more liquid left? What happens when I raise the temperature on this container? 60 degrees, 70 degrees, 80 degrees, 90 degrees. The pressure doesn't come up any higher because there's no liquid left. Did I explain that better this time, or better last time?
A little bit better this time.
Okay, good. That's what we wanted. Better this time. I'll just tell you this one last time if that was confusing for you guys. The initial pressure test that we just did does not tell us, without running the car, does not tell us if our system is fully charged, but it will tell us if our system is almost empty or empty. Right? No pressure, system's empty. If we were at 60 psi right now on a 90 degree day, what we would say again, we're low on charge, we have a leak, we know where we're going. With this one being 90 psi, we can't say it's fully charged, but we can say there is at least some liquid in the system and our pressure temperature relationship is correct. Let's run the car now and see the state of our charge. So that's what we're gonna do now. All right guys, so I'm inside the car, starting it up, blower position, turning on one of the speeds, hitting the AC button, green light lit, AC should have turned on. Let's go under the hood, look at our pressures. As we were filming that part, Pete informed us that this car was in a flood. We had some floods here a few weeks ago, and when Pete first got the car, the horn didn't work at all. It was making some weird noises. The horn was actually underwater. So we have some potential for flood issues here with this. And this is kind of matching that from a standpoint. If you look at my gauges right now, they haven't moved. I'm still at 90 on the low, still at 90 on the high. This clutch has not turned on. In fact, it's a little bit lower now. Did you notice this a little bit lower? It's less than 90. Why is that? Because we're now in the shade. It's not quite 90 degrees today, and the system has cooled down. So our pressure temperature relationship, again, in motion right there. But here's the thing, clutch did not engage. Difficult to see on this one. See if I can get you a shot. You see the little knob sticking out of the front of that pulley right there, right where the square is around it? That should be spinning with the AC compressor. It's not. The clutch is not engaged. But our pressures told us that. Our pressures told us the clutch is not engaging at all. And so the customer putting his own refrigerant in this, basically what he did, if he got any in at all, is he overcharged the system. Now, back to our analogy, picture my container with the liquid in it. Is there a way to tell it's overcharged with our pressure temperature relationship? And the answer is no, because there's a whole big area where we can put more and more and more liquid in, but you still have vapor area and your pressure temperature relationship is going to be fine. So an overcharge cannot be identified by a static rest pressure test. A fully charged system cannot be identified with a static rest pressure test. A near empty and empty system can be identified. What this test again tells us, we have enough refrigerant, this clutch should be turning on. And so we have a lot of different ways and directions we can go now. We can start checking the relay, which we started to do off camera because I wanted to get done quickly. We were able to identify, I had my son help me, this is a faded cover, but we were able to identify this, or was it this one? This one being the AC relay. So we can go right to the relay and start doing some checks. That's one method, using simple tools, a test light and whatever else. Another one, because this is a newer vehicle, it's computer controlled air conditioning, is I can connect my scan tool and see if we have any fault codes, and I should also be able to see inputs. So inputs with the scan tool, we can verify things like the AC switch. Is the signal getting to the computer? Are there any fault codes related to the system? High and low side pressures potentially, depending on the design and if those inputs are available. So really scan tool is not a bad way to go. Some of you may not have a high-end scan tool that can communicate and get air conditioning information, and so this next part won't be helpful to you, but we will certainly be doing some relay checks in here, so keep watching. We'll get to this relay. On this car, I'm going scan tool next just to see if we have any fault codes. All right, so you can see this is a 2008 Mazda 3, 2.3 liter engine. For those of you following along, wanting to fix your car, I'm going to do a full system code scan on this. I have no engine codes. There are no codes in any of the systems. Doesn't mean we're done with the scanner. Go to my air conditioning system. I got a no comm here with my AC system. That's not good. No communication. It didn't give me that. See, the thing about this, I don't know enough about this system. Does it use a separate AC amplifier that's on a CAN network and these all talk to each other? That's what it's maybe looking like. Oh, cool, we got some AC signals. Let's go inside the car. We'll come back to that no comm here in a second. If you look at, and this will be for you too, Caleb, I want you to be able to see this. See the air conditioner request signal says on?
Yeah.
See that data PID right there says on? And watch that same data PID. We'll do this AC cycling switch too. Let's see what else. Refrigerant pressure switch module. Hit this button. That should have said off. Air conditioning request signal still says on. Now you would want to make sure you're not in defrost, because some of these modes, like on Fords, if you're in any of the defrost positions, it'll automatically have the air conditioning on. So even though that stayed on when I turned that off, I might still be in air conditioning mode because this is still a blend here. Let's go to floor. Yeah, it's staying on. That's not good. AC compressor cycling switch says on too. It shouldn't.
Now it says off.
Yeah, but that was the blower. I don't like that. This should be changing on and off with this. All right, notes for the back of our mind right now on the reaction of that. I want to come back to this for a second. This no comm that we have with our heating, ventilating, and air conditioning system. Must be on, engine off or running. No communication, right? If that's on a network, we should have communication errors, and I'm not getting any of those. And so what I've found on some of these systems, so it's not even listed here. So there's no codes in any of our systems, and the fact that I have a no comm on the HVAC module and that it's not listed here tells me that it's probably not available on this car, and this is a scan tool thing as far as the no comm goes. Because if it was actually part of a network, we would have failures in these other modules that would say no communication with the HVAC control unit. We don't have that. So our no comm on the scan tool was because that feature is not available on this car. That's my guess. That's my guess. So scan tool's not helping us. We're getting away from the scan tool now. Really, for the rest of this, we're gonna do some relay checks underneath. I'm gonna stop this scan tool recording. See, my safety glasses have now been taken off. I'm not messing around with the refrigerant and the gauges anymore. So my glasses are off. Some of you are gonna be like, "You took your glasses off." Yeah, so. All right, so I'm using a tool here from AES. You have this, you'll find this on my tool page on my website, links for this guy. You don't need this tool. You can do relay checks without it. But since I own this tool, I won't do relay checks without it. It's just that awesome. So what I'm doing, taking the AC clutch relay out, matching it up to my tool, plugging this guy in, plug it into the back of the tool, can't get it wrong. And what we know right away, see the LED light on? That means the computer is controlling this relay. So the LED light, this is control side, right? And that clutch should have been, this might just be a faulty clutch because that tells me this relay was energized. In fact, let's see if we can hear it click. Yeah, here, listen. Yeah, so that is telling me, again, that red light is telling me the control side is energized and that this is just simply most likely a clutch issue. Tell me if that light goes out when I hit my AC button, Caleb. Is it still on?
Still on. It's off. On.
All right, so what you missed, Caleb, is when I hit the AC button inside, it turned the LED light off, but never turned the control side of the relay off.
Yeah.
It was the blower switch, again, which is the same thing the scan tool showed us, reacted the same way. So in other words, the AC request signal stayed on until I turned the blower switch off. I'm not worried about that. I don't care that there's an issue with that, because here's the thing. The relay is being energized. We should have power to my clutch. My AC compressor should be turning on, okay? So now I'm not worried about control side anymore. Control side of the relay would be the computer's turning the relay on, saying to the clutch, turn on. So that means I don't care about any of my inputs. We have an output problem. From the relay load side contacts right here to the clutch down there, we have a load side contact. We have a load side issue. So this tool, there's no relay in here anymore. I can actually take the load side and I can turn it on. Nothing happened. And this light, I think this light should actually be lit right now. I still have to get familiar with this tool. There's things that this tool can show me without my test light that I might be misquoting here. I think we might be missing power to this. Find out with my test light.
Power to what?
Power to the load side. So we're missing load side power, I think. I'll tell you in a second. One of these two should be hot. Okay, there it is. There's my load side feed. This one goes to the clutch. Right there is my switch. Clutch is not turning on. Okay? And the other thing with this is telling me there's an open. I'm pretty sure that this bulb is wired for the load side contact, that if the circuit is intact, it'll find a ground through the winding of the clutch, and that light should be lit on the load side now. And I'm pretty sure.
So is it the continuity to the...
Continuity, yes. Yeah, we've done this like with fuel pump circuits.
Yeah.
I apologize. There's certain aspects of this light on the load side that I have questions on. Doesn't change how I'm going to approach the diagnosis. Here's the thing. We got good load side power. Load the circuit, switch is on. Power did not disappear, right? That's still good. This is the load side feed to the clutch. So it's basically taking this red and attaching it to the green. Switch off, light is off. Switch on, light is on. That clutch should be turning on. It is not. We need to get a measurement down there. But there's another thing that we can do, and that's where this light comes in here, I believe. But if I take my test light to battery positive, let me get to the battery. So test light to battery positive is what we're doing now. Notice my light lights when I find a ground. On a good clutch circuit, this should be lit. Just like a fuel pump, Caleb. Picture power going into here, going down to the clutch, through the windings of the magnetic clutch to ground. It should be lighting my test light. What's this tell me? We have an open between here and the clutch. Most likely we got a faulty clutch. What we need to do is a measurement down there.
To see if there's still power.
To see if there's power down there. So when I flip this to power and I'm gonna switch my test light back to ground, the last test we need to do and then we're done is on this green circuit, which is the load side feed down to that clutch. When I switch that to power, I should have power down there and ground. Check my ground. If they're good, we're done. We need a clutch. The last part of this is we got to get underneath this car. I can't get to it from the top.
And if there's no power down there, then...
If there's no power down there, then we have an issue in this box.
Yeah.
Or in the harness.
Yeah, I was thinking harness.
And I'm not worried about the AC reaction inside on this car.
Okay.
I don't care that the switch inside reacted to where the clutch was running, you know, the circuit was active all the time. I don't care. What I'm trying to fix is get that clutch engaged. I'm not worried about that input anomaly. I am not. It doesn't help us at all. Some cars, they will have that clutch circuit activated when you don't even have the button pushed for dehumidification. Some cars will turn the AC clutch on to stabilize the idle speed. So there's variables with cars, and without reading description and operation on this system, I'm not going to panic about the blower switch is the only way I can shut the magnetic clutch off. Don't care. Here's the point. The clutch isn't turning on, right? At all. Our issues on the load side. We got to get to that. I don't know if I can. Let me shut this car off. The rest of our checks we really can do with the engine off, because that's the beauty of this tool, is I'm just using the circuit itself, which is active all the time. This is a hot all the time circuit, and I can just flip the switch and do the rest of my checks now. So we need to check that power down here. Can I get to it is the question. Now that we got this car super hot, that part was underwater, Caleb.
Yeah, I know.
See if you can get a shot of this control arm down here. Straight down there, that whole bottom metal bracket. You can see mud all over it.
Yeah.
And that's down in that area is where this AC compressor is. Jack and jack stands, pull this wheel off. I'm on a hill. This is front wheel drive. What happens when I take the front wheel off the ground? The transmission park pin is now up in the air if both wheels come off, and now the car can roll. Bad stuff. Pull the e-brake on, which I did off camera. Also, off camera, I threw the transmission in neutral to check to make sure that my e-brake actually holds this car in its position. And it does. Okay. So am I safe to lift this front wheel now? Yeah. Are my back wheels holding? Yeah. And we don't want to trust just pulling the brake on and saying, yeah, we're good. So here would be the scenario. You're broken down on the side of the road, flat tire. You need to change that front tire. You're on a slope. You're on a hill. People get killed all the time with this kind of thing. Pull the e-brake. Make sure it holds. Throw it in neutral. Make sure the e-brake is what's holding. Now go ahead and jack that front wheel off the ground. If it's a front drive. If it's rear drive, then you got to change up what you're doing. That was more of a lesson for my son. Some of you will appreciate it. Caleb, you have any questions on that? Does that make sense? Real quick shot for everyone. Jack stand. We're being safe. Granted, we're in a gravel parking lot that's not ideal, and I'm not putting my legs under this rotor just in case. We also have the e-brake on, and we are safe with what we're doing. So, just trying to gain access to this AC clutch. You know, I probably could get to the wiring to it from the top, but you guys would never be able to see what I'm doing. So this is more for Caleb to be able to see and for you guys to be able to see. Ah, that's cool. I've never seen a design like this. So one of the things that I did not consider when we were talking is this has a separate belt for the AC. So here's my crank pulley, here's my AC clutch, and it uses a separate belt. So one of the things that I didn't consider, because I saw the serpentine belt spinning at the top, I just assumed it was on the same drive belt. Remember we just did that alternator job in the driveway, Caleb, where we were missing a belt. Yeah. Well, we could have had the same problem. Although our test with the test light would have passed the battery test, the battery positive, it would have read through the clutch to ground. So that told us it wasn't a belt. But just something to consider is like, this has a separate belt. Here's your clutch wire. And so what I'm saying is, if it was just a belt that was off, the test light would have lit when connected to battery positive, because it would have found a ground through the power wire, in through the coil ground, it would have lit the test light. So that test told us we had a clutch issue, but as I'm in here now, I see there is a separate belt. So that's pretty cool that they use a setup like this. The wiring for that wraps around and it comes up. That's what I thought. I thought it was this wire, and I can access that from the top. Let me just eyeball one more thing here. See where the clutch gets its ground. There's a connector right here, back of the compressor. Can't see a ground location. So this clutch end, this is getting changed anyway. And I'm using my Phil's electrical probe. Freaking love this tool, man. It's got a little bed of nails on the end of it right there. So I'm gonna hook the compressor wire right at the clutch itself. Move this insulation back. This is all going to get changed with the clutch.
So it doesn't matter.
It doesn't matter, exactly. And if it ends up being no power here, then I can just fix this with some liquid tape, not a problem. And it leaves such small holes. It's just going to be my easiest way to do this for where we are right now. So we're clear. You see my test light? So my switch off, switch on. I'm sending power down there right now. We'll extend this over, we'll reach up. Let's get to a ground. Check my test light. Good, we're lit. And then I'm gonna touch the end of my Phil's electrical probe.
It's lit.
Yep.
So you have power to the.
Yep.
So you need a new.
Needs a clutch. I'm gonna reach up and flip the switch off, flip the switch on, flip the switch off, flip the switch on. Sweet. So my wiring is good from up there
down
all the way down to here. Switching my setup now, back to battery positive. When my test light finds a ground, it's gonna light, okay? That should be lighting right now.
It's not, because it can't find a ground through the clutch?
Through the clutch itself.
Gotcha. Sweet.
So some of you are like, what? Give me 1 second. This will be my lesson.
All right.
So the AC clutch, all it is a coil of wire, makes a magnetic field. It's electromagnet. Has a ground on one end, and then this would come up to my relay. Okay? I'm just draw the load side. Now what I'm doing is I'm taking, well, we did two things. The last test that we just showed you, I put a test light right here, and I connected that test light to ground, and I flipped the switch on my tool. Flip the switch, I close the switch, send power this way, light lit. How's my circuit from the relay box out to the clutch?
It's good.
It's good. No problem, no opens, right? Flood's not an issue. Now the flood could have damaged the clutch. We have to worry about this ground. Here's the thing. It's not, there's no ground wire.
Oh.
So the ground is on the housing itself. Yep. Of the compressor. There's no test for that. I can test the compressor housing. We can do that. In fact, here, before I go any further,
you're gonna do that? I'm
gonna do that right now. Right. And what we're gonna do is we're gonna load the circuit. I'm gonna go back to ground with my test light. We'll come back to the power explanation here in a second, the open circuit explanation. So right now, if I flip my switch, I'm sending power down there. We're gonna go confirm it again.
All right.
Okay. How do you test a clutch ground? Is first you load the circuit. Is the circuit loaded right now? Is my test light lighting on my tool? Yes. Yes. Circuit's loaded. All you need to do, touch the housing. If the ground was bad, my test light would light.
It would be lit
on the ground of the housing. It would light.
How?
Because it's open, and if there is no ground, there's no voltage drop, and so it would actually light on the housing.
That's so weird.
I'll refer you guys. I have a couple of bad block ground videos where a faulty starter and where the car wasn't cranking, and I could make my test light on the engine block. Yeah, I'm gonna make you watch it, Caleb.
I'll watch it.
So it's that simple. With no ground wire on this, if my housing, so if this clutch, it does, based on what I'm seeing, it grounds on the housing of the compressor itself. That would mean the compressor doesn't have a ground, right? If the ground was bad, that means the compressor itself doesn't have a ground. And if the compressor doesn't have the ground, so we send power in the coil, and then it goes through and then goes into the ground of the housing. And if the housing isn't grounded, the housing just becomes an extension of the winding. And so it will light on the housing. This is my ground test. The fact that my test light is not lighting on the housing says I do not have a ground problem.
Okay. That makes sense.
Okay. And then we'll back that up with some timestamps and some other videos with bad block grounds and how you can have a housing light a test light. Okay, just to reiterate that, where's this ground? It's on the housing of the compressor, okay? And so what's the ground of the housing of the compressor ground to? It grounds to the block. So realistically, we could have a mounting point problem between the housing and the block. So we're sending voltage in, goes through the coil, goes into the ground, and fills the housing with 12 volts because there's no ground to the block. So when you touch your test light on there to ground, it would light, telling you have a bad block connection ground problem. Not our issue at all. All right. Final part. We connected our tool. Let's redraw this. Clutch, ground. Here's our tool. Switch is open. I now am connecting my test light to battery positive. And what I'm looking for in this test is I wanted to see my test light travel through, go through the winding of the coil into ground. It should have lit my light. Most compressor clutch coils will draw 2 to 4 amps, somewhere in that range. My test light, I'm having trouble with my pen. My test light only draws about 200 milliamps. No problem lighting that test light through the clutch coil circuit. It won't be as good of a ground as a straight ground, but 2 to 4 amps, that's a real low ohm circuit. That light should be bright, okay? So when we did that test, that told us what? Open in the wire, or open in the clutch coil, or open ground.
And we checked the
Which
ground
two
and the
did we
wire.
check? Yes, we checked. Very good, Caleb. We checked the ground, we checked the wire. Where's our open? Clutch coil. Done.
Sweet.
Hope that makes sense, guys. I'm not sticking around for the replacement of this clutch. You guys that are following along, we get a lot of requests for AC videos, AC repair type videos. This would be one. You could say hi to Lenny here behind my right shoulder. He's in the background. Lenny's a longtime friend. But guys, please follow these procedures. These are standard practice. This is another faulty clutch on this car. And again, I apologize. I'm not going to be here for the replacement of this. I don't know if it's going to get a whole compressor or if the clutch is available separate. My friend Pete Latour at Latour's Auto is going to handle that part. I've shown enough to troubleshoot this thing. Again, we are not worried about the input side of this. The input side's irrelevant as far as the reaction of the blower switch and the AC button. I don't care. We have enough information here that this is absolutely a faulty or open clutch coil. Guys, thank you very much for joining me. Special thanks again to Caleb Danner, cameraman Caleb behind the scenes. And again, for more information on this stuff, you want more training, go to my website at scannerdanner.com and join my classes online. Scanner Danner Premium for $11 a month. You cannot beat the type of training that I'm providing on that channel. Right now, there's 350 videos, 200 of them being classroom type lectures where I'm teaching fundamentals and principles. Then we start applying all this stuff. I look forward to hearing your comments. You guys are on the fence about joining Scanner Danner Premium. I have a special request for you Scanner Danner Premium members. Please put some comments in this video about what that channel, Scanner Danner Premium, is doing for you guys, because these other people need to hear it. Thank you guys. I'll see you next time.